Images of space can be amazing, but have you ever wanted to make your very own? NASA's Astrophoto Challenges invites you to do just that. You can select data from telescopes on Earth and in space, choose colors to apply, and produce your very own expression of the universe. For this year's challenge, we take you into the gaseous and dusty embers of the Carina Nebula, where new stars are being born, and one star in particular, the erupting Eta Carinae, is nearing the end of its life. In the Micro Observatory Challenge, you get to control an Earth-based robotic telescope to take your very own image of the Carina Nebula using visible light. In the NASA Datasets Challenge, you have a selection of images taken across the spectrum of light, X-ray, visible, and infrared, that you can mix and match into your own unique view of the Carina Nebula. Or you can make your own image of the iconic erupting star system Eta Carinae with additional datasets in X-ray, ultraviolet, visible, and infrared light.
Please make sure to share your image with us. Tell us about your creative choices. Why did you use the color schemes that you did? Were your choices scientific, artistic, or both?
Now go create your own astronomy photo by selecting either the Micro Observatory Challenge or the NASA Data Challenge. Or try both.
Hi, everybody. My name's Phil Lamar, and welcome to NASA's Ask the Astronomers Live, the show where you can ask real astronomers your own questions as we chat about some of the most amazing things in the universe. Now, as the video you just saw said, NASA's 2022 Astrophoto Challenges has just begun. Now, this year's Astrophoto Challenge target is Eta Carinae, which was once the second brightest star in the night sky. Now, these days, it's a lot fainter, but it is surrounded by an amazing nebula. And with the Astrophoto Challenge, you can take some of NASA's really cool tools and make your own images of this amazing nebula. All right. Now, today, I'm going to be speaking with two astronomers who will educate us about this kind of weird star system and how you can play with the same data that professionals like them also use. Now, for those of you that are joining us live on Facebook or on YouTube, go ahead, use the chat, use the comment section there, say hello. We'll see it live. And please send in any questions that you have, because there's a lot that are going to come up with this discussion, I guarantee it. Also, this is something new. We have a survey about the show that we would love for you to be a part of. You'll get a $5 gift card if you fill out the survey, and that will help us make the show even more entertaining. The links for the survey should be right below. And also, after the show, make sure you visit our website at universeunplugged.org. Once you go there, you can watch all sorts of fun astronomy videos, find out about upcoming episodes of this show and other shows, and make sure you don't miss our next amazing topic. Let's get to today's. Now, to talk with us about Eta Carinae, and let me know if I'm pronouncing it right, are our guests, Dr. Rudaparna Das and Dr. Nathan Smith.
Hi.
Hey guys.
Hello.
Thank you guys for joining us. Nathan, can you please tell the audience a little bit about yourself and your work?
Sure. All right. So I'm Nathan Smith. I'm a professor in the astronomy department at the University of Arizona. And I teach classes to undergrads and graduate students. But when I'm not teaching, I'm also doing research. And the primary focus of my research is on the lives and the deaths of massive stars like our target today, which is Eta Carinae. And I study how they evolve before they die, and then how they finally die in supernova explosions and some of the other crazy things that they do.
Wow. The life and death of stars. Rutuparna, actually, that's so long. I'm just going to say, Rutu, how are you?
I'm great, thanks. How are you?
Thank you for coming back to the show. Now,
Yeah,
for the folks who didn't see your last show, tell the audience a little bit about yourself and your work.
Yeah, hi everyone. I'm Rutu Das, and I am an astrophysicist and science communicator at the Center for Astrophysics at Harvard and Smithsonian. So, well, that's a lot of words. What I do is I spend part of my time studying the universe, trying to figure out what it's made up of, how it's changing over time, and looking at data from the skies to help figure that out. And the rest of the time, I get so excited about space that I love sharing it with everybody. So I spend my time making everything from, things that go up on museum displays to writing stories about how we learn about space to doing this, talking to you all about how you can explore space.
Ah, wonderful. Okay, so you're back east figuring out what the universe is made of. And Nathan, you're in Arizona, is it?
Yeah, I'm in Tucson, Arizona.
In Tucson. Okay. Well, that's not quite the spread of a galaxy, but you guys are pretty far apart. Now, tell us what you guys are doing there in Arizona, there in Massachusetts, when you're not figuring out about stars and the universe. What do you do, guys? What do you guys do outside of your astronomy work?
Rutu, do you want to go first?
Sure. Okay. Excuse me. When I'm not doing astronomy work and when I'm not coughing and sneezing because of allergies, I really love poetry. I like to read poetry, but I love writing poetry. And sometimes it'll be astro related, like it'll be like parodies of famous songs. Like I did an ode to the universe for You Are 16 Going on 17 from Sound of Music. And sometimes it'll be, completely random and different. So yeah, I love to read, I love to write. And then I get interrupted by my dog, who is thankfully very peacefully sleeping at my feet right now. But if you hear barking, please excuse that.
Oh my gosh, Rutu, that sounds like a TikTok channel waiting to happen. I want to hear those song parodies.
Oh man, am I gonna have to join TikTok now? I have to think about that.
Nathan, what are you up to?
Yeah, so I got to astronomy pretty late in life. When I was a kid and in high school, I was mostly into visual arts. I was a painter and did drawing and painting and stuff. And then I got really into music and I actually went to college. I majored in music, and so that's mostly what I do when my time isn't taken up by teaching or research or my kid. I play music. I play guitar and other instruments with strings mostly, and I play sort of weird avant-garde jazz and loud, heavy rock kind of music.
Okay, excellent. That's amazing. We got to get you some club dates, and Rutu, we got to get you a TikTok. All right. But before we get to that, let's figure out about Eta. Wait, is it Eta Carinae or Eta Carina?
You'll get different answers from different people. I pronounce it Eta Carina, but some people pronounce it Eta Carina. Some people, it's like Carina, tomato.
If only Caesar was here to tell us how it's pronounced.
Exactly.
We can just shorten it and say Itacar.
Oh, all right. I'll go with that. I like things that are shorter. Let's talk about Eta Car. Now, Nathan, I understand that you have, I guess, a personal connection to Eta Car. Is that true?
I don't know how personal it is. I mean, I spent a lot of time doing research on this star, and it was actually the first project I worked on as an undergrad. Like in the summer, you have a research project that an advisor gives you, and mine was working on Eta Carina. And so that's how I got started working on it, and I never put it down. I work on other things too, but I never really left it. So wow. My first project was actually can we see the image of that Hubble image of the nebula? Yeah, so you see this nebula around Eta Car, the stuff that's sort of inside the blue and red stuff. There's this double bubble, this dumbbell-shaped thing. And it turns out that that's expanding very quickly. And so my project as an undergrad was I measured how quickly it's expanding by using images taken at different times. You can actually see it growing. And so I tried to work back in time to figure out when this material was ejected by the star. And it turns out that it was ejected in the middle of the 19th century, at least from our point of view. And so then, that raises a lot of other questions. And I've been, usually with Eta Car, when you solve one problem, you uncover many other problems. There's many really interesting things about this star that are mysterious, and we don't have enough time today to talk about them all. But the key thing about it that's really interesting is that it had this huge explosion in the middle of the 19th century when it ejected this nebula. And by the way, that nebula contains like 10 times the mass of the sun. Oh, wow. The mass of our sun. But the star that's left behind is about 100 times the mass of our sun. So it ejected its outer layers in this huge explosion, but the star survived. And the star itself is just that really small white point of light at the center, and it's surrounded by this cloud of gas and dust that obscures the star, which is why it's one of the reasons it's a lot fainter today than it was in the middle of the 19th century. So we think this object is among a class of stars that do this periodically. They become unstable and eject a whole bunch of mass, kind of like volcanoes, how volcanoes become unstable, have an eruption, and then settle down in a dormant period, and then maybe do it again. And so this star did something very violent in the middle of the 19th century when it became very bright and ejected all this mass. And the chief mystery about it is why. And so we try to, it's like looking at the archaeological record or like a crime scene investigation. You try to find all the little pieces and put them together and try to understand, what physics caused this star to explode and why it looks the way it does. So that's that's what I spend a lot of my time doing, and trying to find different types of clues. And what you're seeing here in this picture is there's like a series of nested nebulae. So the double bubble thing there is in the middle. And then there are those streaks that you see, those blue streaks. That's actually light that is sort of sneaking out of the holes in the nebula. And then the red and purple stuff that's even further outside that are basically shock waves from older eruptions where it's running into stuff around it. So the purple here is X-rays taken with the Chandra Space Telescope. And when a blast wave crashes into material, it tends to make it very hot, and it emits X-rays. And so that's what you're seeing. There's sort of this nested, Russian doll structure of nebulae inside of other nebulae. And it's because there's been a series of explosions that have made this really, complicated and beautiful nebula that we see now.
Wow. That's amazing. Well, actually, two questions. One from Mary Dussault. Is there a historical record of people seeing Eta Carinae in the 19th century?
Yes, there definitely is. And in fact, that's how we know about it. So the main observer was an observer at the Cape of Good Hope in South Africa named John Herschel. He's the son of the famous William Herschel. And he started noticing that for unexplained reasons, it was getting brighter and fainter and brighter and fainter. So he kept track of it, and then other people started paying attention. And it did this over a period of about 20 years. It was getting brighter and fainter, and then it stayed bright for 10 years, and then it basically disappeared from view. And part of the reason is we think it ejected all that mass you see in the nebula, but it also formed dust, and that dust obscured the star and made it dark. And actually, that dust now absorbs a lot of the star's radiation, but it re-emits that radiation in the infrared. So the dust gets heated up, and it's like the predator seeing a worm thing. It's like it emits in the infrared, and so now Eta Carinae is one of the brightest things in the infrared sky because it's emitting all of its light in the infrared.
Fascinating. Now, Nathan, a quick question. In addition to Mary's, the sort of dumbbell bubble part, what is that made of? Is it invisible to invisible light, or just in other? spectrums.
Yeah, if you could look through a telescope, in fact, I have looked through the eyepiece of telescopes and you can see it. Yeah, so you can actually, even though that's a Hubble image, you can see it with your eyes too. You can see that double
Really?
bubble shape. And the white part
Wow.
anyway. And what you're actually seeing is starlight that's reflected off of dust. So it's like smoke particles and sand particles, basically, that are reflecting the starlight. And so it just looks kind of white because the starlight is mostly whitish. And the clumpy, so that's all made out of material that used to be in the star that has been ejected in an explosion. And the dark lanes and clump, kind of looks like cauliflower or something. The clumpy stuff is because the gas, as it expands, it cools and forms this clumpy structure. And so some parts are darker than other parts.
Right. Well, I mean, you have, like you said, a visual background, and I can see why you might have stuck with Eta Car, because visually there's so much going on here. I mean, in terms of, what it reminds you of, metaphors like cauliflower, dumbbells, bubbles, But now, Rutu, let's get back to the Astrophoto Challenge, since we're talking about how amazing this thing looks. Now, people can make their own images of Eta Car?
Yeah. So you all saw that beautiful picture of our cauliflower dumbbell. Okay, I'm never stopping calling it that now. And that combines several different kinds of light. And what you can do now is we've set up a way for you to use real professional astronomical data from NASA and ground-based telescopes, and you can actually make your own image of this. It's actually, this combines several kinds of light. And why don't we show you? We have a little demo here. And, this is just our interactive website. You can go there. There are tutorials, by the way. And you can load up real data. This, the one that's about to load up, this is from NASA's Hubble. And you can process it and make it look clearer. And you can change the colors to make it look prettier. Because the data we get from the sky is mostly, is there light or not? And how much of it is there? So it's just black and white. But then you can add a different kind of light. We're now adding some X-rays from NASA's Chandra X-ray Observatory. And you can, color that however you feel like. And, there are a lot of fun palettes there. Feel free to play with them. And then the really cool thing is this program will just put them together for you. You can blend the two images. So here you have optical light, visible light that our eyes can see, and X-rays. But you see that like the bright star point in the center of both are sort of off. This will also align it for you. So now we see that the parts that we can see with visible light is actually much smaller than this giant cloud of gas, of really hot gas that we have around that's shown in X-rays. So you can work with real professional astronomical data and make your very own image, and then you should send it to us.
Oh, wonderful. And that's an Astrophoto Challenge right there. Now, just looking at these images is incredible. But Nathan, back to what you were talking about before about the fact that this is sort of a volcano star that blows up, calms down, and then, because it's, I mean, certainly as a, layman, when I've heard of stars blowing up in the past, it's just the idea of a supernova. It blows up and it's gone. This idea of a volcano type of star where it blows up but keeps going is so strange. But unlike a volcano where everything that it throws out just lands and tears up an Italian city, what this star has thrown out has formed this nebula.
Right. Yeah, and so we're observing the nebula to try and pick it apart to learn about the chemical abundances, like what it's made out of, how fast it's moving, how much mass is there. So that tells us how much energy was in the explosion and when it happened, and the shape, that double bubble shape tells us something about whether the star was rotating or if it was two stars. In fact, we know that Eta Carinae is actually, today, it's two stars that we see orbiting around each other. And that probably influenced the shape that you see a little bit or a lot. So there's all sorts of fascinating questions that, clues that lead us to learn about the physics of the eruption that happened. Because like you say, most people think of the way a massive star dies as a single final event in a supernova. But it turns out that, so Eta Carinae is probably the most massive and most luminous star that we know of in the Milky Way. It's a real monster. And these stars they don't just explode once, they seem to become unstable before they finally die. And when they finally die, they'll make a black hole. But before that, they have these sort of fits of anxiety, where they're kicking material off of their surfaces because they're becoming so unstable, because they have so much light that they actually blow themselves apart.
Huh. Now, we have a question on that topic from Brandon Priest. Why does the sun erupt? I guess he's, why do stars go supernova or explode, or in the case of Eta Car, just erupt in series? Why does that happen?
Well, for Eta Car, we're still trying to figure that out. We have ideas, but we're not settled on it yet. One idea is that this explosion was the result of actually two stars merging together into one star. Right, so that it started out as three, and two of them merged together, and now there's two left. That's one possibility. Like when the sun has eruptions on its surface, you see these prominences on the surface of the sun. Those are much, much lower energy, and it doesn't really disrupt the structure of the sun, right? But these massive stars are blowing themselves apart and ejecting huge amounts of mass. And a final supernova happens because the star is reaching the end of its life. It runs out of fuel, and the core of the star collapses to make a neutron star or a black hole, and that induces an explosion that blasts the star apart.
Got it. So there you go, Brandon. It's the core of the sun, of the star, collapsing. There's nothing left. Well, actually, to go back to the volcano metaphor, if volcanoes weren't tied to, the center of the earth, they would run out of stuff and they would pop like pimples, I guess, on the surface of the planet.
Yeah, they have to have a source of energy, right? You have a hot spot of magma under the surface that's feeding a volcano. In the same way with this massive star, something has to supply that energy, and we're trying to figure out what that is.
Wow. Amazing. Oh, wait. Brandon Lawton has a question. How does the eruption of Eta Car impact the broader environment of the nebula in which it resides? Well, you touched on that just now, but is there any more to add to that?
Sure. If we could show one of those images again, either the Hubble image or the one with a little bit wider field of view. Well, maybe if we can zoom in even a little bit. Yeah, that one's fine. So Eta Car is ejecting all this mass, but this is mass that used to be in the star, and it's actually material that has been processed through nuclear reactions, and it actually changes the composition. And so then this stuff gets kicked out into space, where it's going to mix with the gas that's already there. And so now maybe we should look at that Carina Nebula image. The Carina Nebula image is a much bigger region. It's about 100 light years across.
Wow.
That dot, if you look at the center, there's that keyhole kind of shape, that dark structure just above the V. And to the left of that, there's a bright dot. That's Eta Carina. Okay, so that's the star we're talking about. And it's in this huge nebula. And this is a place where lots of other stars, thousands of other stars, are currently being born. So the stars are being born out of those dark clouds that you see. And they're forming new stars like the sun. And what happens is the material that gets ejected in Eta Car's explosion is going to mix with that gas and enrich the gas with new elements that was produced by Eta Car, and it'll get incorporated into new planets and stars.
Wow. Okay. So yes, that's definitely going to impact the birth of those other stars, because they're not just being born into a vacuum. They're being born into an environment that's filled with the stuff that's been ejected from Eta Car.
Yeah, they're being pelted by material, and they're also getting irradiated by a lot of ultraviolet radiation and shock waves from these explosions. So it might significantly change how those stars and planets form. Yeah.
Got it. Well, that image of the wider nebula is incredible, especially knowing that the, cauliflower dumbbell's way down there in the middle. But Rutu, our viewers can actually take pictures of the nebula themselves, right? Is that true, using robotic telescopes?
Yeah, that's the second part of the challenge. And, it would be really cool to see our cauliflower dumbbell through a telescope. The nebula you can actually see through your eyes. Unfortunately, though, only from the southern hemisphere. As this is a NASA program, I'm imagining most of our viewers are in the northern hemisphere. But if you're not, then you're lucky. It's great. But what you can do is you can tell one of our army of robotic telescopes, and by army I mean 3 robotic telescopes around the world, to take your very own picture, your very own image of this Carina Nebula. And you can do it by going to our micro observatory website. I'll just show you really quickly. You can see there's so many targets you can choose. You can pick the Carina Nebula, or, if you want to have fun, you can pick some other things. Pick the types of filters you want. And then the next night, one of our telescopes will take your very own picture of that nebula and email it to you. And then you can open it up in that other thing we were looking at, and process it yourself. So yeah, that will be data that nobody else has or has had. They'll have similar data, but that will be your very own picture. And, you can, excuse me, and then you can process it. You can add different filters of it to make a full color image. You can do lots of things. So if you go to our challenge website, that is called the Micro Observatory Challenge, because our network of telescopes is known as Micro Observatory. And the other part, which we were talking about earlier, with using real professional astronomical data from NASA and ground-based telescopes, that's called the NASA Data Challenge. And you can do both. Feel free.
Okay, so the NASA Data Challenge and the Micro Observatory Challenge. But that's amazing that people can book their own time on, one of Rutu's army of 3 ground-based telescopes. That's incredible. And they can take that image that's sent to them and add it to the Astrophoto Challenge. That's great. All right, so for anyone who joined us late, this is Ask the Astronomers Live. I'm talking with Dr. Ruta Parnadas and Dr. Nathan Smith about NASA's Astrophoto Challenge and the Eta Carinae Nebula. We've had some great questions. Brandon, Brian, thank you guys. And anybody else who's got more questions, keep them coming. And for those of you watching on Facebook or YouTube, you can just put it in. Yeah, there you go. Like Frank Sienkiewicz did. Just put them in the chat, and we'll bring them in. We're talking. Okay, let's get back to the erupting star Eta Car and how people can make images of it. But let's get Frank's question. Frank says he has a simple question. What are those 3 blue stars to the upper left? Are those part of the nebula or just happen to be there from our perspective? Oh, okay. In this image.
I can answer that. Thanks for the question, Frank. Those blue stars, we've actually gotten spectra of those, so we know what they are. They are stars that are neighbors of Eta Car, not just along our line of sight, but actually in 3-dimensional space. They are members of the population of stars that have been born inside the cavity of the Carina Nebula. And so they are, they're probably the same age, and they formed at the same time as Eta Carina, but they're a lot less massive than Eta Car is.
Got it. Oh, interesting. Okay, so those are some of the stars that you were talking about when we were looking at the broader nebula image.
Exactly. I should elaborate a little bit. So Eta Car is just the most massive and most luminous of probably about 70 or 80 stars that are really massive stars that were also born in that nebula, and they produce a lot of ultraviolet radiation. They light up that cavity that you see that's inside the Carina Nebula, and those 3 are 3 among those 70 or 80 really hot, massive blue stars. They're just not quite as massive as Eta Car.
Got it. Right, right. It's so fascinating, the fact that, I mean, because those of us non-astronomers, when we think of stars, like, well, there's the one big sun, and it doesn't uh, occur to us a lot that there's a variety of stars. Because, in elementary school, you're taught there's a variety of planets, but not a variety of stars.
Right. Yeah, there's a huge variety, and it's largely determined by how much mass they have when they're born, and also whether or not they have a companion star in a binary system. Like the stars that Tatooine orbits around. There's a lot of binary systems of stars in the Milky Way and in other galaxies, and they're actually very common. And those two stars orbiting around each other can actually interact and exchange mass with each other, and they can do some pretty crazy stuff. So yeah, there's a wide variety of different kinds of stars, and they have a variety of different kinds of lives and deaths when they finally die.
Actually,
Wow,
yeah, it's
wow.
funny. Our sun is really weird for being a single star, right? It's like it's solo, it's doing its own thing, but that's not the common thing at least in our galaxy, or we think in the universe, right?
Yeah, I mean, I
Oh,
think
and that's oh, sorry, go ahead, Nathan.
I was just going to say that for massive stars like Eta Car, they're almost all in binaries. I mean, there's a large fraction are binaries, and then when you get down to the sun, single stars are a little bit more common, but there still are a lot of binaries. Yeah.
Fascinating. Now, Eta Car is part of our galaxy, right?
Yeah, it's part of the Milky Way. It's in a separate spiral arm from us, so it's about 8,000 light years away from us, but it's in the disk, the flat plane of the Milky Way.
Right, right. Yeah, it's not some faraway galaxy. Is that why you're able to see it with ground-based with actual visual telescopes on a visual level, as opposed to if it were in a faraway galaxy, you couldn't see it from Earth, right?
Yeah, and even within our galaxy, it's pretty close, relatively speaking, because there are a lot of other regions of our galaxy that are blocked by all the gas and dust that's in the Milky Way. But our line of sight to Eta Car is pretty clear, and so we can even see it in the UV and the optical, and it's near enough that when we use Hubble, we can get really spectacular images of it. And in fact, I guess if we'll see in this zoom out that it's like we're going out from the inside of the cavity, and our line of sight to the star is relatively unimpeded by all of those clouds of gas that you see. If one of those had been right along our line of sight, then it would have been hidden. So we're kind of lucky in that respect.
Fascinating. And of course, that raises the question of, are there stars this big, that close, that are blocked by something?
Yeah, there are some, similarly massive stars, although this is arguably the most massive that we know of in the Milky Way. But there are others that are also monster stars that are not as easy to see, because there's some in the galactic center and near the center of the Milky Way, but they're totally blocked at visual wavelengths. So we have to study them in the infrared. And then there's some in other galaxies too that we can see them, but they're much farther away. So it's harder to see the kind of detail that we can get with Eta Carinae.
I see. Now, do you guys just feel so excited to know that you're looking at something that Galileo looked at, but you're able to see it because you have the technology to see it on other spectrums and get so much more data and information about it, but they're the same stars that, astronomers hundreds of years ago we're trying to find out about, but so much more.
Yeah, it's pretty sweet. I mean, it's a good time to be alive if you're an astronomer. There's a lot of great data that we can combine, not just visual, but visual with Hubble, but also ultraviolet and infrared and X-rays and everything else. It's really spectacular.
And as you said, it's a really cool feeling to think the skies are basically connecting humanity over time, because as you said, we're seeing the same stars, probably slightly differently in the sky. Well, we know slightly differently in the sky because our galaxy moves and our solar system moves within the galaxy and everything. But it's funny, the ancient Egyptians aligned the pyramids with several stars.
Oh, wow.
And we can see those stars today, and we see that they've shifted slightly because, as I said, our solar system's moving. But it's really great to think of all the millennia of humanity looking up and to the universe, where this is like a very short amount of time. So we're just all looking up at mostly the same stars.
Yeah,
Right.
could I elaborate on that just a second? Because before we get to this question, I wanted to mention that before I talked about how we have this historical observations of the 19th century of Eta Car getting brighter, but there's even more before that. Like Halley of Halley's Comet fame observed Eta Car and recorded how bright it was a few hundred years before that. And there's even stories that we're not too sure if they really apply to Eta Car, but there's stories of the Babylonians that had this red star that would come up just above the horizon, and because of the Earth's precession at that time, you could have seen it from ancient Babylonia. Like maybe they were seeing the star when it was having a previous eruption. There's but those are pretty speculative, but it's still fun to think about, connections like that.
Yeah, that's incredible. That's amazing. Okay, and thank you, Rutu, because when I become pharaoh, I'm going to make my pyramids on wheels. But Brandon Lawton has a question for you. In the study of erupting stars, this touches on the growth of technology. How will NASA's JWST help us learn more? That's for those of you who don't know, which probably anybody watching this show does. That's the James Webb Space Telescope, which was just recently launched. But how will JWST help us learn more about erupting stars? Who wants to take that one?
I could take that. I mean, I guess it's sort of funny. I mean, they're not going to let me point JWST at Eta Car because it'll melt the telescope. It's so bright. When I tried to observe Eta Car with the Spitzer Space Telescope a few years ago, I had to be very careful to go look. I would look around Eta Car, not right at it, because it would have destroyed the detectors because it's so bright. So JWST won't be so useful for looking at erupting stars like Eta Car in our Milky Way, but what it could potentially do is help us study examples that are similar in other galaxies that are much farther away and much fainter, and study them in the infrared. So we're really looking forward to that.
Okay, right. And maybe draw parallels between the infrared data from those stars in other galaxies to the infrared data we have on Eta Car.
Yeah, because when you have an object like Eta Car, it's kind of a freak, and you want to understand how it fits in sort of in the broader picture compared to other stars. And so you need more examples if you can get them.
Right. There you go. Rutu, what's next for the Astrophoto Challenges?
Yeah. So once all of you lovely viewers take your own images or use professional data to make your own images, or both, send them to us, and then we will be going through the images, and several standout images will be chosen, and we'll get comments from real NASA scientists. And we've done this in the past several times, actually. We can show you some examples of some of these standout entries that we got before. There you go. These are all from previous challenges, and you see people have so many different takes on what each object is supposed to look like. And please send us your images. Like, don't think that, like, don't worry if you've never made an astronomical image before. I'll tell you a little secret. Many astronomers, many professional astronomers, have no idea how to make these pretty pictures. We rely on our image technicians for that. Thank you so much. So we're all in the same boat here. We take the data, we try to understand it, but we're all like, except for a few of us who do this really well, we're all pretty much novices at making these images. So show us your take, and maybe we will give you some feedback.
Got it. Excellent. All right. Well, thank you guys so much for giving us so much information about this incredible star and about this incredible program, the Astrophoto Challenge. Although, Nathan, I'm guessing if they ever put together an Astro Music Challenge where you get to take NASA data and turn it into notes, you're going to sign up for that, aren't you? I
might have to, yeah.
So, fun fact, I have to say, because Phil, you mentioned this, now I have to say this.
What?
We have indeed taken Edakar and turned it into sound. It's called sonification. So we're trying to exhibit real astronomical data in many different ways, because not everybody learns best by seeing, and many people can't learn by seeing. So Irakarne is one of the many objects that we have taken and turned into, I say sound, but some of them are really music. And actually, if you go to our challenge website and scroll down, there's a link that says learn more about Irakarne. And if you click on that and scroll down, you'll find all of these resources. We have the sonifications, we have these 3D prints, and we have all the files for these online. This is a 3D print of that cauliflower dumbbell that we were looking at. And all the files are online. So if you have access to a 3D printer, either at your library or school or somewhere, maybe at home, you can just download the files and print your own erupting cauliflower dumbbell. Like I said, I'm never stopping calling it that. But yeah, all of that is on the website. So please go explore.
Oh, that's amazing. Okay, I got to take that link and give it to the Futurama writers. They have a 3D printer in their office. And the show's back, so hopefully they're back in the office. Guys, again, thank you so much. This has been fascinating. Now, before we finish up, are there any final thoughts you want to share with the audience, or future events you want to let people know about? Nathan?
I don't have any future events, but I guess a final thought is that I've thought about Edakar a lot, and I've actually played with making a lot of these color images myself, aligning them. And when astronomers do this, it's usually in service of some scientific goal, like we want to illustrate where some blob is next to another shockwave or something. And so we're usually not thinking of the goal of being artistic when we're doing this. We're trying to serve a purpose. And so I'm actually really curious to see what sort of color images people might come up with when they're not concerned with that, when they're actually more interested in making a beautiful image, because there's a lot of really cool structure in these images to work with that you could probably bring out by adding together things in a multicolor image. That would be really cool. So I'm curious to see that.
Excellent. Rutu?
Yeah, I will just plug the challenge again. That is our current activity that is going on. Please send us your images. Feel free to go explore more about Edakar and the Carina Nebula. And however you like to interact with this data, whether it's through the science of it, or whether it's through the visuals of it, or like me, whether it's like through trying to write poetry about it. By the way, Phil, I think you said something like Edakar, the erupting star, and now that's just running off in my head. I might have to write something. But yeah, however you choose to interact with it, play with the data, become one with it, and join our NASA family and send us what you make.
Yay. Art and science. Bonding.
Definitely.
I love it. Thank you guys so much for joining us today. And thank you, audience, for joining us to learn about Itacarinae and how one can image this amazing star and its nebula. Now, you can see the video of this show that we just had, as well as all of our other videos at universeunplugged.org. Or you can just click on the link that's there in the comments. Make sure you subscribe to Universe Unplugged on YouTube or follow us on Facebook so that you won't miss the next great show like this one. And please fill out the survey and get a hold of that $5 gift card, because we'd love to hear what you guys are interested in, and that'll help us shape the shows to come. But until next time, I want to thank Dr. Nathan Smith, Dr. Ruta Parnadas. Thank you so much for sharing your expertise and your hobbies.
It was a pleasure.
I'm Phil Lamar, and this has been Ask the Astronomers Live. Thanks for watching.
Thanks, everyone.
Bye-bye.
Bye.